Hello class, in this video we're going to start section 2.1. We're going to learn how to solve linear equations 3 different ways. So before we get to that, let's first talk about the difference between an expression and an equation. An expression does not have an equal sign, but an equation will have an equal sign. So if you look over here, you'll see we have x plus 2 equals negative 3. The x plus 2 by itself would be an expression, but once I add the equal sign, we now have an equation. So x plus 2 equals negative 3 would be considered an equation. X plus 2 by itself is an expression. Negative 3 by itself is an expression. But when we put it all together with the equal sign, we have an equation, right? Same goes for this example, right? 3 times the quantity of x plus 2 by itself is an expression. Once I add the equal sign, we have an equation, right? So we're really setting two expressions equal to one another. So we have a practice problems. It says for exercises 1 through 5, determine if we have an expression or an equation, right? So again, remember, if there's no equal sign, it's an expression. If we have an equal sign, it's equation. So it looks like expression, equation, equation, expression, equation. Take a moment to look at these 5 problems. Maybe you want to pause the video for a moment. So these are the correct answers, right? And again, the equation has an equal sign, and the expressions do not. Okay? Let's keep working. If we scroll down a little bit, we're asked to verify that a number is a solution to an equation. Okay? So if you take a look, it says verify that 4 is a solution to x plus 6 equals 10. The way we would verify that would be plug in the 4 to the variable, or plug in the number to the variable, and then ask yourself, is 4 plus 6, does that actually equal 10? And we know the answer is yes. Right? So 4 plus 6 equals 10. So we can say yes, 4 is a solution to the equation x plus 6 equals 10. Okay, let's try a few practice problems. Okay, so for the next 6 problems, we're asked to verify. Again, we're not going to do all of these. The answers to all practice exercises can be found in the back of your book. So let's take a look at maybe number 6. Verify that negative 4 is a solution. So I'm going to take negative 4 and replace the x with that negative 4. So if I'm going to use, so I like to rewrite the problems. So I'll rewrite 3. And now anywhere I see a variable, I'm going to replace with an open set of parentheses. And then I'll drop the variable into those parentheses. So this negative 4, I'm going to put in here. So now I have negative 4 minus 1, which is negative 5. So I have 3 times negative 5 equals negative 15. And then 3 times negative 5 is negative 15 equals negative 15. So I can say that negative 4 is indeed a solution to the problem. Okay? I'm going to try one more. I'm going to do number 10. And I'll erase all of this stuff. Okay, so take a moment if you need to copy this or practice maybe 7 and 8 on your own, and then we'll try number 10. Okay, so for number 10, we're going to verify that negative 3 is not a solution. Okay, so that means both sides will not be equal when we're done. So again, I'm going to replace my x's with the negative 3. So anywhere I see x, I'll write negative 3. So I'm going to rewrite the problem up here. So I'm going to have 3 times negative 3 minus 1 equals 5 times negative 3 plus 1. So negative 3 minus 1 is negative 4. So we have 3 times negative 4 equals 5 times negative 3 plus 1 is negative 2. And we end up with negative 12 equals negative 10. So this is a problem. So put not a solution. I'll abbreviate solution by just SOL. Okay, and that's really all they're asking you to do here. Right, so a good test question would be, instead of me saying is a solution or is not a solution, I might just ask, is -4 a solution, yes or no? Right, or I might say, is -3 a solution, yes or no? And then you'd have to show your work. Next, we're going to try to solve equations symbolically. All right, so we're going to solve equations symbolically, and it talks about one-step equations. So some of the rules are we're going to try to isolate the variable on one side of the equation, and we can do that using either the addition property of equations and then the multiplication property of equations. And really, you could do addition or subtraction and multiplication or division. Right, so when you look at example 2, right, if I want to solve for x, right, I can use the addition property, right, if I add 1 to both sides of my equation, right, the 1's cancel, leaving me with just x equals -15 plus 1 is -14, right? So that would be my answer for letter A. And I can use the multiplication or division property, right? If I divide both sides by 3, I'd be left with x, right? Because 3 over 3 is 1, equals -5, right? And I can always check my work by plugging the -5 back in or plugging the -14 back in, okay? So in these two problems, we really were able to solve these with just one step. But what about two-step problems, right? We'll take a look at those in a moment. On the next page, they have an example of some problems that will require two steps. So I want to rewrite some of these problems. Let's look at letter A, okay? So I'm going to rewrite letter A over here. Right? So I have 7x minus 1 equals -15. So my first step, right, is to add 1 to both sides. And I'm left with 7x. -1 plus 1 is 0. And -15 plus 1 is -14. So that was my first step. I added 1 to both sides. My second step will be to divide both sides by 7. And I'm left with x equals -4 over 7. All right. So I'm going to stop here. This will be the first of several videos covering section 2.1. All right. Thank you for watching.